Welcome to Introduction to Statistics. In this video, we're going to be talking about what a histogram is. In the last video, we talked about what a frequency distribution is. And what a histogram is it's pretty much a graph of a frequency distribution. So given this frequency distribution, its graph represented with this histogram looks like this. So the way you read this is with each of the different classes, there is a bar, and how high the bar is depends on the frequency. So for example, with the first class, between students between ages 15 and 18, there were 24 of those students. That corresponds to the height of this bar. And one other thing you'll notice is that the y-axis of a histogram is the frequency, and the x-axis is the age, or whatever data that we're tracking. In this case, it's age. So the importance of a histogram is that we're able to analyze the shape of the data and look at the distribution of the data more easily with a histogram. And it's also important to note that histograms can be generated using technology. So in this class, what's important is that we know how to read it and also know how to create just create the bars that represents the frequencies. Here's another example of a histogram. So here we have the frequency distribution and its corresponding histogram. And if you guys remember from last time, we talked about converting a distribution, a frequency distribution into a relative frequency distribution. So given this frequency distribution, its relative frequency distribution is here. We can also graph its relative frequency distribution. So there it is. So the only difference with this histogram and the one on the last slide is that here the y-axis or the vertical axis are percentages because we're dealing with relative frequencies, percentages, as opposed to frequency. And another important thing to note is if we go back and we look at the shape of the histogram for the frequency distribution, you'll notice that the shape of the relative frequency histogram is the same shape. They have the same shape. So relative frequency histogram has the same shape in horizontal scale as its histogram. So what's also important is that we know how to interpret histograms and look at the different shapes of a histogram, as I suggested earlier. One of the very important shapes of a histogram or a distribution is is a normal distribution. When graphing, normal distribution has a bell shape, and here are two very important characteristics of a normal distribution. The frequencies increase to a maximum and then decrease. And the other one is that it's symmetric, with the left half of the graph roughly a mirror image of the right half. So take this histogram, which displays this normal distribution. This is a normal distribution. Again, it increases to a maximum and then it decreases, and it's relatively the same. If you cut it in half, it's mirror images of each other. So it's not perfectly mirrored, but as long as it's close to mirror, we would say it has a normal distribution, which is again a bell-shaped curve. There are other types of distribution. So for example, we can have a skewed distribution. So a distribution of data is skewed if it is not symmetric and extends more to one side to the other. So for example, the one on the left has a right, skewed to the right, has a longer right tail, and the distribution on the right is skewed to the left, and it has a longer left tail. There's also something called a uniform distribution. That's where data values are approximately the same frequency. So take a moment, pause the video if you can, and identify each of the shape of these four histograms. So the one on the left, we see that it has a longer tail on the right, which means this is skewed to the right. This one right here has a longer left tail, so this would be skewed to the left. And this one down here, if you see it increases, it starts low and increases, and it kind of tops off around here, and then it decreases gradually, and then it tails off like that. So, and also if you were to cut it in half, you'd see that they're almost mirror images of each other. It's not a perfect mirror image, but close enough. And that one we know is a normal distribution because it has a bell-shaped curve. All right, and then the last one, it's approximately the same frequency with each of these bars. So this one is a uniform distribution. So hopefully that all of that made sense. If not, feel free to email me.